Okay, in this presentation we are going to look at complex numbers and how we can use them to deduce proofs for trigonometrical functions, essentially, or trigonometrical equations. So use the Moivre's theorem to prove the identities. So cos 2a equals cos squared a minus sine squared a. That's our first one. Okay. And the second one is show that sine 2a equals 2 sine a cos a. Okay. So this is actually quite short and sweet, this one. So essentially what we do is we'll start off with this expression here. Cos a plus I sine a to be squared. Now essentially this is apropos of the fact that the question asks us to use the Moivre's theorem. So this is our sort of starting point. Just as a remark, if you were to calculate the modulus of this, you would find that the modulus is equal to 1. So r is equal to 1, and that means r to the power of n is 1 to the power of n, which is 1. Essentially what we're going to do here is we're just going to disregard the modulus because it's 1 and nothing really happens after that. Okay, so theta here is in this case is a, and n is equal to 2. Okay, so n theta is simply 2a. So essentially what happens here is this expression here ends up as cos 2a plus I sine 2a. Okay, that was straightforward enough. Okay, so remember now, this is essentially a straightforward multiplication. So essentially, I'm going to approach the same thing again. This expression here, I'm going to approach it again, but this time I'm going to just multiply it out conventionally. So cos a plus I sine a. So essentially what we do is we end up with cos squared a plus 2I sine a cos a. Okay. And then I squared sine a squared, sine squared of a. Okay. So again, this is very straightforward. X squared plus 2xy plus y squared. That's sort of very simple multiplication of a squaring of x plus y squared. Okay, that's simply all we're doing there. Okay. Now I realize it looks a bit clunky, particularly when I handwrite it. Anyway, so what we have here, essentially what we're going to do here is we're going to bundle up all the terms. So cos squared a and I squared sine a squared. Essentially that's minus sine squared of a. Okay, so we're going to just bundle them up there as our real parts. So that's the real. There. And this part is the imaginary. Okay. Okay. So just actually going back to when we looked at de Moivre's theorem, this was the real part here. This was the imaginary part. Okay. Essentially what we do is we let them equal to each other. Okay, so cos 2a is equal to cos squared of a minus sine squared of a. That's the reals equal to reals, and the imaginaries equal to the imaginaries. Sine a squared, cos a squared. Oops. Okay, that's it. Thank you very much.